So we've taken some time to take up that initial transformations package, or at least the end. You guys can kind of go through, look through the solutions with like a finer tooth comb and make sure that you've got all the little sketches and all that kind of stuff all good to go. Okay, in the package, you were introduced to this weird looking function, okay? The package basically told you that this is our general transformation equation, and g at x is the transformed function. So maybe we'll just make a little list over here. So g at x is representing the transformed function. F at x, this part right here, is representing the base function that we start with. We call these parent functions, without any transformations. So in your package, you were introduced to 3 base functions that we're going to be looking at in this unit, which are the quadratic, the square root function, and that rational function that you graphed at the beginning. So this will be like the base function or the parent function. We call it a parent function. Okay, and then everything else in this, all of these guys, these variables here, a, k, d, and c, these all represent different transformations that we can use to change the base function. Okay, so a, k, d, and c represent different transformations that we can do. Different transformations done on the parent function. Okay, so that's kind of the breakdown of this like weird looking function here. So let's talk about a, k, d, c. I just want to kind of do a recap here. We took up a little bit from the package, but we're going to kind of go through and talk about like what each of these does, and then we'll see what we can identify and stuff like that. Okay, so firstly, there's a specific order of transformations that needs to be done, and it kind of connects to bed mass. So we know in bed mass standing for brackets, exponents, division, multiplication, addition, subtraction, we know that multiplications and divisions must happen before what? Any additions and subtractions here. So if you looked at a, k, d, and c, and you looked at the operations that are happening here, what would you assume needs to be done first and at the end? Jack, what do you think? Sorry, say that one more time. A and k at the start and c. Okay, so a and k are transformations. We can see them, they're being multiplied, right? This is multiplication when we have like brackets or it's outside of something. These are additions and subtractions, the C and D. So those have to be done at the end. The multiplications need to be done at the beginning. So we must do all A and K transformations first. These would be stretches, compressions, and flips. We'll talk a little bit more about that in a second. All D and C transformations will be done after, at the end. Which would be basically any translations. So if we're going to shift the function left or right or up or down, that has to be done at the end after we do the stretches, compressions, and flips to the function. Okay, and then again, the reason for this is because of bed mass. A and K are multiples or multiplication. D and C are additions, subtractions. Okay, so there's two types of transformations, like in the umbrella of transformations, which would be vertical transformations and horizontal transformations. We're going to talk about the vertical ones. So you guys know, like when we look at like an x and y axis, the y is like the vertical axis and the x is like the horizontal axis. So if I'm talking about vertical changes, I'm referring to the changes of the y coordinates of the graph if it's a vertical change. If I'm talking about horizontal changes, I'm talking about changes to the x coordinates of the graph. Okay? So y coordinate changes, these would be caused by the a and c values in this AKDC equation here. Okay, so let's just, this is going to be kind of like a repeat of what you guys summarized at the end of your package, but I think it's good for us to make sure that we're all on the same page with this. So A transformations, there's a couple things that A can cause. If A is greater than 1 or less than -1. So as a sample, Sophia, give me something greater than 1. Anything. 3. Give me something less than -1, Evan. -5, okay. So both of these things are going to produce vertical stretches. So imagine you took your graph and you kind of like, if you imagine like an elastic, you're kind of stretching it out up and down. That's the idea of what we would be doing if A falls in either of those categories. Okay, and usually we would say this, like in plain English, we would say vertical stretch by a factor of, and then you would say like, I'm going to say absolute value of whatever A is. And I'll tell you what absolute value means in a moment, but I'll give you a second to copy this first. Okay, so we're going to practice with writing some of these like in English, just so that we can get the hang of what all these transformations do. Has anyone seen the absolute value sign before? Alan? Okay, so you've come across it. Have you seen it before? Do you know what it means? Okay, so if you see these bars on either side of your variable, it basically just means, well, usually we would put in a number in there. Basically just means it makes everything positive. So when we say vertical stretch by a factor of whatever A is, for instance, as Evan said, if A was less than -1 and it was -5, I would want to say vertical stretch by a factor of the absolute value of -5, which would just be 5. We don't include the negative because the negative part is actually a separate transformation. So just positive, the positive version of A. Okay, absolute value makes the number positive, makes everything positive. Okay, so that's the first scenario. We could have something greater than 1 or less than -1. Second part of this is we could also have A is between 0 and 1 or between -1 and 0. Okay, Raul, I want a value in between 0 and 1. Give me an example.
0 and 1.
Must be between that.
0.5.
Okay, 0.5 or a half, in other words. Okay, I want something, Nicholas, in between -1 and 0. Give me an example. Yep. Sure. Give me another one, Duncan. Sure. -3/4 or something like that. Okay, these cause vertical compressions to happen. So imagine you take your graph and almost like you're putting it in a machine that's going to like squish it vertically. That's kind of the idea. And the way that we're going to say this in English is we're going to say vertical compression It'd be very similar to what we have above, except instead of stretch, we'll have compression by a factor of the absolute value of A again. So we just want the positive version of that, whatever it is. Okay, and then the last thing that we can have that sort of falls into these two scenarios is if we have that A is negative, that's kind of a separate transformation aside from the stretch or compression option, which is if we have an A that's negative, it causes what we call a vertical reflection. So that's the last one for A. So if A is less than 0, or in other words, A is negative, we would basically just say vertical flip or reflection, whatever you want to call it. Okay, and for that one, this is literally what you would say. You would just say vertical flip or reflection. You don't need to say the by a factor of, because that would be included in the compression or the stretch part. Okay, so those are your vertical stretch, compression, and reflection scenarios. So if something falls in this range, these two ranges, so Evan gave us an example of -5, we would say a vertical stretch by a factor of 5, and the negative part of that is a vertical reflection. If we had something like what Nicholas said, which would be -0.5, in the range of -1 to 0, we would say vertical compression by a factor of 0.5 and vertical reflection for the negative part of that. Okay, so the negative part of it basically just means you have the compression and then also the flip, or the stretch and also the flip. We can't have a stretch and also a compression at the same time, but we can have a stretch and a reflection, or we can have a compression and a reflection if the value is negative. Okay, C is pretty straightforward. If C is positive, so in other words, greater than 0, the graph will shift up. So we will say shift up C units. So if C is 3, we'll say shift up 3 units. If C is negative, or in other words, less than 0, we will say shift down. I will say absolute value of C units. So I'm not going to say shift down -3 units. I'll just say shift down 3 units if C is -3. Okay, so C is basically just an up and down shift. Just going to shift your graph up and down. Okay, this is kind of like we're just laying the foundation, so there's a lot of kind of new stuff, getting used to the words and getting used to all of that kind of stuff for this lesson, okay? Can I scroll? Okay, horizontal changes, because these are changes to the horizontal and on a XY graph, X is the horizontal. Horizontal changes will be changes to the X coordinates of the function. So K, let's talk about K. If K is greater than 1 or less than -1, this is going to cause, it's actually kind of the opposite of what A is. This causes a horizontal compression to happen. So imagine again that you put your function in a machine that's going to squish it coming from the left and right. So imagine like metal arms of a machine coming and squishing your function like this. We would say this as horizontal compression by a factor of 1 over K, and we're going to say the absolute value of that. So when I say 1 over K, basically I'm saying the reciprocal. That's what 1 over something means. It means reciprocal. And the absolute value is basically just saying the positive version of that, because the negative is a flip, right? The negative part, if you had a negative. Okay, so if k was, Thomas, give me an example of k greater than 1. 4. So if k was 4, I would say horizontal compression by a factor of, what's the reciprocal of the value 4? Happens when I flip that. Alan? Nope. 1 over 4. So flip the fraction, not the sign. So I would say horizontal compression by a factor of 1 over 4. Okay? Give me k is less than negative 1. Give me a sample in that, Ryan. Value less than negative 1. Something smaller than negative 1. Anything. Okay, so negative 5. Horizontal compression by a factor of, what's the reciprocal of negative 5? Negative 1 over 5, and then we take the absolute value. So we would just say horizontal compression by a factor of 1 over 5. And then the negative part is a flip. It's a horizontal flip. Okay, so we'll add that to our list in a second. Okay, we can also have values of k in between 0 and 1, or in between negative 1 and 0. And these cause horizontal stretches to happen. So imagine you took your function and pulled it out horizontally toward the left and toward the right. That's a horizontal stretch. And we would state this very similarly. We would just say horizontal stretch by a factor of the absolute value of 1 over k. So still we're doing reciprocal. Okay, so give me a sample, ideally in fraction form. Give me an example of a fraction that falls between 0 and 1. Can anyone do this? Alan? Fraction, though. Okay, 1 over 4 works. So 1 over 4, that falls, it's 0.25. It falls between 0 and 1. So if it's 1 over 4, I would say horizontal stretch by a factor of, what's the reciprocal of 1 over 4? 4 over 1. So in other words, 4. So I would just say horizontal stretch by a factor of 4. Okay, k is kind of a weird one. We always have to remember to kind of do the reciprocal of the k value because it does the opposite of what we kind of expect it to do. Okay, and then the last thing is if k is negative, so in other words, if k is, whoops, I wanted red there. If k is less than 0, or in other words, negative, it is going to cause a horizontal flip or reflection, whatever you want to call it. Either word is fine. Okay, and that's exactly how we'll say it as well. We'll just say horizontal flip or horizontal reflection. Oops, this is supposed to be a K. All right, and then the last one is the D value, which is a left and right shift. You guys may have noticed in that package that you were doing that the D value, it looks different in the equation than what it actually is. So if D is greater than 0, or in other words, positive, it will look negative in the equation. This is going to shift the graph. We would say this is a shift right D units. So if D is 5, we'll say shift right 5 units. And if D is negative, it will look positive in the equation. We will say shift left the absolute value of D units. And I say that because if D is negative 7, I'm going to say shift left 7 units, not shift left negative 7 units. The negative part is the left part, so we don't have to say negative there. All right, so that's a lot of kind of preemptive setup material and stuff like that. This is kind of what our goal is to kind of get down through this unit, is understanding when things are certain types of transformations, what they do to your function, and we're going to practice this again and again and again with different functions. So by the time we get to the end of this unit, the hope is that we've practiced this so many times that this stuff is all kind of internalized and we know what it is right away, and we can do it to any kind of function. Okay, we'll focus on 3 main functions in this unit. Okay, so this is basically like all your setup info for this unit. It's important to kind of have this down. You can look back at this until you feel confident like doing this stuff for yourself. Okay, so we're going to do a practice. Okay, so remember, this is our transformation equation where we have A, and then it looks like this. It's on your first page as well, but okay. So sometimes we will have one transformation, sometimes we'll have multiples, and we need to kind of identify whether it's an A, a K, a D, or a C. You guys actually did this at the end of your package as well. Okay, so we have a negative in front of f at x. Would this be an A, K, D, or C? What do you think? It's technically a -1 in front. It is an A, and we know that because it's kind of like in the position that A is in here. Like if you kind of look, it's something in front of f at x, so that should tell us that it's an A value. So this is an A value of -1. Now, if I multiply something, I know this is -1, but if I multiply something by 1, does it change? No. So is this going to cause a stretch or a compression at all if multiplying something by 1 does not change it? But if I multiplied something by like 2, then those numbers will grow, right? So a value of 1, it actually doesn't fall within any of these, right? It's not greater than 1, it's not less than -1, it's not here, it's not here. That's because there's no stretch or compression. But what happens when A is negative? What does this cause? What happens when A is negative? You can look back at your sheet if you need to. Not a stretch. Sorry, I heard it somewhere. Flip. Vertical flip right here. When A is negative, it's going to cause a flip. Okay? If you see any other number than 1 here, then you also have a stretch or a compression that goes with that. When it's 1, 1 doesn't change anything. If I multiply by -1, the only thing it does is it changes the signs of the coordinates, right? So this is going to be a vertical flip. That's all we need to say. Or if you want to be fancy and you want to say vertical reflection, then you can be fancy. Okay, guys, do we need to like stand up for a second here? Maybe I'm feeling like a lot of people are kind of tired. Let's take a minute. I will pause. Take a minute, stand up. Okay. All right, let's continue. Okay, so what do I have here? A, K, D, C. I'm just going to call people out, so you got to be on your game here. Ryan, what is 3? Is this an A, K, D, C? What would you say? Okay, so A is 3. All right, Liam, I want to know what is the +2? You're right. And because of this negative in the original transformation equation, D is always opposite of what it looks. So if I were to enter in something that would cause that to be positive, I must have actually entered in a -2 to make that negative and negative, make it positive. So D is actually the opposite sign of what it looks. D is -2. Jack?
Should we think of D like the same way we think of like restrictions?
Kind of.
Like
Kind of. Yeah, you switch the sign of it.
Yeah.
Yeah. Okay, and Sophia, -1. C. Okay, I want somebody to tell me what A of 3 does. Look back at your sheet if you need to. What does this cause to happen? Vertical stretch, and we will say this as vertical stretch by a factor of 3. Good. Is everyone cool if instead of writing by a factor of, we just write BAFO by a factor of? Because we're going to write it a lot. Okay, So by a factor of, maybe just for this lesson's sake, I will say this means by a factor of, just in case you're looking back at this. Okay, I want somebody to tell me, what does a d value of -2 do? Jack.
It should, it looks, wait, it shifts, left by 2.
Good. Shift left 2 units. Good. And who can tell me what a c value of -1 would do to our graph? Well,
Shifts down 1 unit.
okay, c is an up and down shift, so this one, because it's negative, it's going to shift down 1 unit. Perfect. So if I had a function, basically this is telling me, take that function, stretch it out, then we're going to shift it left 2 units, then we're going to shift it down 1 unit, and then we'll be done. Liam? Yep. Okay. We're going to keep practicing, because the more you practice, the more you'll kind of get to know what does what and how to identify all of these. Okay, so I want to know, what is 2? I'm going to choose Nicholas. What is 2? A, K, D, or C? It is an A. Very good. So we have an A of 2. And the 1/3, is it? Okay, it is K. So K is 1/3. Okay, Duncan, can you tell me what an A value of 2 does? You can look back at your notes if you need to. What does an A value of 2 do to the graph? Okay, vertical or horizontal? Let's start with that. Vertical. Okay, who can help him out with what it does vertically to the graph? Evan? Vertical stretch, perfect. So we will say vertical stretch by a factor of 2. Okay, this one's the tricky one. This is the K value. It's kind of like opposite of what the A value would do. Alan? It is a horizontal stretch by a factor of 3. Very good. So we use the reciprocal of K always when we state the transformation. So this one's going to be horizontal stretch by a factor of, so we'll just do BAFO for that, reciprocal of 1/3, which is 3. Horizontal stretch by a factor of 3. Good. All right, next set, -5. Ethan, what's -5? AKDC? Okay, A is -5. Maddie, the -1/4 in there. A, K, D, or C? Okay. Whoops. 1/4. Okay, the x plus 2 part, what does that tell us, Jack? F?
Yeah. Or wait,
It's an A, a K, a D, or a C. Those are the options.
wait, which is the number again?
The plus 2 here. Ryan, what do you think? It's a D. So if you look up here,
That's what
just these ones. Okay. You said F, yeah. Okay, so it's a D, and what would we say? D equals -2, because we have to switch the sign of D. Okay, the last one, the +7, Alan, C. Okay, Sophia, what do we say when A is negative? What's the negative part? What does that do to my graph? Okay, so we're going to say vertical flip, or reflection, whatever you want to call it. If you're fancy, you say reflection. Vertical flip, and then I want to know what the 5 part does to the graph. Alan, what do you think? Okay, so we'll say vertical flip and stretch by a factor of the absolute value of A, so just the positive version of that, right? So by a factor of 5. The negative part is the flip part, the 5 part is the stretch part. So when we say vertical flip, we've taken care of the negative, and then we'll say and vertical stretch by a factor of just the positive version of that, which is 5. So that's perfect. Okay, Evan, when K is negative, what does this do? Just this negative part. Good. So we're going to say horizontal flip. And then I want to know what 1/4 does. Alan? And stretch. Okay, it's between -1 and 0, so that causes a stretch to happen by a factor of the reciprocal and the absolute value. So make it positive and flip it by a factor of 4. That's it. Okay, so for K, we always need to make sure once we state that transformation, we're going to use the reciprocal. The flip is the negative part. The stretch is the 1/4 part. Okay, last two are easy. What does a D of -2? Question or answer?
Yeah, question.
Okay. Anytime it's negative, when you state the transformation, the flip will be the negative part, and then you talk about the other part as the stretch or the compression or whatever that is, so you don't have to put the negative in front. Okay, D of -2, Jack?
Shift left 2 units.
Shift left 2 units. We actually had that one above as well. And C of +7. Who feels like they can answer this? What does this do to our graph? Look back in your notes if you need to. Say it again. Okay, so we will say shifts up 7 units. Or you can say translate if you want to be the fancy person. Shift up 7 units. Okay, so this is basically what we're going to be practicing. I think we'll save this part, these little parts here, and we'll just focus on this for today. So you're going to go through, we'll stop it here. We've got like 20 minutes left of class. I'm going to save chapel we'll do that Thursday together, if everyone is fine with that. So let me pull up the workbook here. Let's talk about what we want to do for that workbook. So basically what we're going to do is we're going to do this front page. These you can save for later. You are going to go through and you're going to identify the A's, the K's, the D's, the C's, and you're going to write in words what those transformations do, basically what we just practiced in the lesson. The more practice you can do with this, guys, the better, because this unit, like this is the foundation of all the rest of this unit. So I want to encourage you guys, like I know there's quite a few questions here, but there's a reason for that, and that's because I want you guys to get to know what different things do, and you should be able to identify A, K, D, C, okay, and know what they do. So we're going to practice that. I think you could probably get most of this done before you leave today. That would be my thought. So let's aim for that. And